I think one of the key things that is right now on top of every organization and every sort of executive is how do we trust AI? And when you talk about trust, you want to go into the domain of explainability of AI. In order for us to believe what the AI is predicting, we really need to know what's happening under the hood. There are different techniques out there right now. So one of the good starting points in terms of fintech and what we do for our clients is to really provide them visualizations of what features are actually driving a particular prediction. So someone can go up to an algorithm and apply for a loan, and the algorithm would say, okay, you're not eligible. The next immediate question is, okay, why was it not eligible? So then you need to provide really that really granular understanding of what feature exactly contributed to that particular prediction in the first place. One of the things that we recommend are frequent retrains that needs to happen on the AI models so that the AI model is constantly adopting to changes in customer behaviors, because the data that you're capturing, the new data that you're capturing, that essentially gets incorporated when you do the retrains. So that is a very fundamental step, and this was one of the reasons that we suggested to one of our clients in the South Asian market that in order for the AI to perform at its optimal, you need to have weekly retrains at a minimum, if not daily. So that is one way to sort of make sure that the biases in the predictions go down. Another thing or another approach that we can take is to have multiple AI models predict for the same customer. And research has shown that if you have multiple models and if both models converge on the same prediction, then that's the correct sort of a way to go about. But if there is a distrust between two models, then you can probably have some sort of a technique like averages to really reduce the bias that an AI algorithm has on a particular customer. So we had a situation where our model was performing poorly on the women's predictions. So any woman that applied got rejected. And when we drilled it down, it really boiled down to representation of women's data in the sample that itself. Hence, there are different techniques. One of the techniques that we do is to really mask out any information about gender. So the model does not even have a look at who is male and who is female. Another approach is you need to understand that when you're inferring it on the whole population, the characteristics of people in the rural areas differ significantly from the characteristics and behaviors of people in the urban areas. So if you have data coming in from just the rural area itself, making predictions about people from the rural areas will cause problems.